Hello, class, and welcome to your first notes on a video of 2021. Here we are. So this is Unit 7, Day 2, super exciting stuff. We're going to do kind of like some notes here on the video and then just a couple things in class, including these first two problems. As a kind of a warm-up. These look like there's a lot, but those are actually really quick. So we're going to do those together in class. And here on the video, we're going to skip right to talking about other points of discontinuity. Specifically, we're going to be talking about holes, or removable discontinuities is another name for holes. All right, so that's where we're starting, right here. A hole in the graph, it's going to look like an open circle. It occurs if I factor the top and bottom of the fraction and something cancels out. That thing that cancels out is going to tell me where the hole is. Okay, so the process is going to be the same when we're doing graphing. We're just building on what we already learned. So we're still going to factor the numerator and the denominator first, and then, like I said, if something cancels, then there's going to be a hole. So what we're going to do is take that canceled factor, and to find the location of the hole, we're going to take that and set it equal to 0. All right, that gives me my x value of the hole, and then I'll teach you how to find the y value of the hole. You then will take the simplified fraction, and that is what you're actually going to graph. You don't graph the original, you graph the simplified version. And then, of course, watch your domain and range if applicable. The other thing that I want to say is watch your vertical asymptotes. A lot of the times, students will say, oh, well, there's going to be 2 vertical asymptotes for a problem like this because I can factor the denominator. And you can see that there's 2 numbers. We're going to get x plus 5 and x plus 2 to factor here. And a lot of students would say, oh, there's 2 vertical asymptotes at -5 and at -2, but that's in fact wrong. And the reason why that's wrong is because the x plus 5s cancel. So there isn't an asymptote there. There's actually a hole there. Okay, so let's write down the simplified fraction. The simplified fraction, there's nothing left on top, so I'm putting a 1. And then there's an x plus 2 on the bottom. So taking that is how I can figure out the vertical asymptote. So the vertical asymptote, we set the bottom equal to 0. The vertical asymptote is going to be at x equals -2. Now looking back, let's talk about where the hole is going to be. The hole is going to be at -5. So we take this x plus 5, the factor that canceled, and we set it equal to 0. So there's going to be a hole at x equals -5. And I am going to also ask for the y value. I actually want the hole as an ordered pair. So how to find the y value is you take that x value, -5, and you plug it in to the simplified function. Okay, so we're going to plug into simplified. Okay, so that's what we're plugging into. I get 1 over -5 plus 2, which is 1 over -3. Okay, so the hole is the point, the ordered pair, -5 and -1/3. That's where the hole is actually going to occur. We also found the vertical asymptote, and then last but not least, we also want to find the horizontal asymptote. This is a BOBO, again, bigger on bottom 0. We want to look at the simplified function to figure out the horizontal asymptote. So the horizontal asymptote is at y equals 0. Okay, so I've now done the problem because it asked for the vertical asymptote, check, the horizontal, check, and any other points of discontinuity, which is going to be the hole. All right, so there it is. Now let's graph some problems, okay? We're going to attempt to do 3. I don't want to leave this video being super long, so I actually might cut it off after we do 2, but let's just see how much time we have after doing numbers 2 and 3. 4 is a maybe, okay? We definitely are going to do 1 and 5 in class together. So skipping right away to number 2, I don't want to waste any time. The first thing we're going to do here is factor, okay? So let's factor the denominator. We get an x minus 1 and an x plus 3. So clearly there's going to be a whole. I usually do that part first. Those cancel. I usually just draw an arrow from that canceling and I say, okay, set it equal to 0. So the whole is at x equals 1. But let's find the y value of that whole. Well, I have to plug into the simplified function, which is 1 over x plus 3, to find the y value of the whole. So that's going to be 1 over 1 plus 3. I just plugged in this x value here, okay? And that's going to be 1 over 4. So the whole is at 1/4. When I look at this chart, that's what it's asking where it says point of discontinuity. It's at 1 and then 1/4. Okay, everything else is quick because from now on, ladies and gentlemen, I am graphing my simplified function. So a lot of the times, you know, students who struggle with this, I have them write down like the simplified is 1 over x plus 3. I just always want to write simp, but I think that's like something you guys say, like he's simp for her or something. So I think that's something you guys say. But we're simp for that simplified fraction, okay? We're obsessed with it because that's what we have to graph. All right, so the vertical asymptote from the simplified is going to be at -3. X equals -3. Horizontal, bigger on bottom 0. X-intercept, y-intercept. X-intercept is top equals 0. Well, there's nothing on top. 1 does not equal 0, so there is no x-intercept, and the y-intercept, remember, is the ratio of the constants. So that's going to happen at 1/3. So the y-intercept is 0, 1/3. Let's graph this baby. We might have to find some other points, okay? So like we talked about in class, it's so fun to make our asymptotes with these dashed lines. We have one at x equals -3. 1, 2, 3, here it is. Beautiful. And then 1 at y equals 0. This is why there's no x-intercept, because there's an asymptote there. And let's graph the points that we know about. So hopefully it gives us enough to make the whole graph. If it doesn't, we might have to plug in. So the first point that we know about is at 0 and then positive 1/3. So that's enough to tell me that this part of the function, oh, nice. Well, kind of nice. I actually don't like that. Sorry, guys. Let's do it just like this because what it does, it doesn't make it look like it follows that asymptote. So there's that first part. Oh, I have to also graph the whole. So the whole is at 1 and then 1/4. So I'm actually going to erase this again. 1 and then 1/4. Again, this is like an estimation here. It's going to be a little lower than that last part and that last point. So this is all I know. So I actually don't know if the rest of the graph is going to be up here or if it's going to be down here. So I do need to plug in a point. My suggestion is always plug in something close to the vertical asymptote. So let's plug in -4. And when we plug in, we're plugging into the simplified. So we're going to have 1 over -4 plus 3, which is 1 over -1, which is -1. So I do have a point at -4, -1, which is right here. So sure enough, the rest of this function is in that bottom corner. Okay, so that is that, and I'm done with this graph. Let's do one more, and then we'll do the rest in class. We will do the rest in class. I just don't want these videos to be too long. So here is our last problem. We will do number 4 in class. Our last problem here, and this has another hole, and this is actually my favorite kind, and it's also the most missed on assessments in this class. This is actually, if you guys look at the problem carefully, it's the same problem as number 2, which I just flipped it around. Okay, so when I factor the top, it factors to x, I'm writing it in the other way, but that's okay, x plus 3, x minus 1 over x minus 1. So this is a bizarre situation because, again, the x minus 1's cancel. I do have a hole at x equals 1. But look at my simplified. Look at what's left over. What's left over is x plus 3 over 1, which is really just x plus 3. So this is the simplified version. And the simplified version is just a line. It's not a rational equation. There is no vertical asymptote. There is no horizontal asymptote. This graph is going to be a linear graph, but it's going to have a hole in it. Okay, so it's not just a line, it's a line with a hole. All right, the hole is going to occur at x equals 1. Let's find the rest of that point by just simply plugging into my simplified version. So 1 plus 3 is 4. So the hole is at x equals 1, y equals 4. There is no vertical asymptote. There is no horizontal asymptote, again, because this is linear, but with a hole. I can find the x-intercept. The x-intercept is when I set the top equal to 0. So that's going to be at -3. My y-intercept is the ratio of the constants. So that's 3 over 1. Let's plot all of this. So here's what I know. I know that my x-intercept is -3. Boom. Y-intercept is +3. Boom. Point of discontinuity is at 1, 4. So this is literally just a line with a hole in it. Okay. Again, it's one of the easier problems, but it confuses people. It's one of the more missed problems in this unit. So the way I describe it to students is this. If something cancels and what's left is only on the top, there's nothing left on the bottom, that's when it's a line with a hole. If something cancels and there's something left over, you know, an x on the bottom, then it still is going to look like a rational function, but just has a hole somewhere. Okay, now the rest of the problems on this review they do not have holes. They're just more complicated graphs, and we'll go over those in class together. All right, guys, thanks for listening, and I will see you tomorrow.